Simply supported beam of span L carrying concentrated load at the mid of the span. So we have to draw the simple supported beam. This is a simple supported beam and the load W Newton amount is applied at the center of the beam and total length of the beam is equal to L and the support ends are A and B. So for solving the simple supported beam, we have to calculate that is RA and RB. What is RA and what is RB? RA is the reaction at A. Reaction at A and RB is the reaction at B. Due to the load is applied symmetrically, so that is RA equal to W by 2 and RB equal to W by 2. So that is RA equal to W by 2 and RB equal to W by 2. Then we have to calculate the shear force. That is the shear force. So that is shear force between, we have to, and that is the point C. So shear force between A and C is equal to plus W by 2 and the shear force between C and B is equal to minus W by 2. Why? Because according to the law of shear force, that is left up, right down. Between A and C, that is left side is up and right side is down. So that is positive, and between C and B, that is left side is down and right side is up. So that is negative. Then that is, we have to draw that is the shear force. And the shear force changes its sign from that is positive to negative at the point C. So plus W by 2 and this is minus W by 2. Then that you have to calculate the bending moment. Bending moment. So when we calculate the bending moment, that is distance x from the point A. So that is W by 2 into x, that is mx is equal to W by 2 into x. When x is equal to 0 means at the point of A, that is bending moment is equal to W by 2 into 0 is equal to 0. Then when this point is, that is L by 2 and that is also distance L by 2. So when that is at point C means that is distance is equal to L by 2. So bending moment is equal to W by 2 into L by 2 is equal to W L by 4. So the bending moment is increases uniformly from that is 0 to the value W L by 4. Again, that is the bending moment is that is maximum at point W L by 4 means at point C, and that is decreases up to 0 when that is at point B. So the bending moment is maximum at the point where the shear force changes its sign. That is the point A and that is the point B and this is the point C. Here is also A, B and C. Here is W L by 4. And in next point we have discussed about when the load is applied eccentrically. that is the load is applied eccentrically. Load is applied eccentrically. So first we have to draw, that is the simple supported beam A and B, and this is the point C, load W, and that is distance from A to C is A, and from distance C to B is, that is point B. So first, that is we have to calculate RA and RB. So how we will get RA? Here the load is not in symmetrical, so that is eccentrical. So first we have to calculate RA and RB. So we are taking moment about A, taking moment about A. So when we are taking moment about what, that is W into A equal to, that is clockwise moment, and RB into L, that is total distance in L. So that is anti-clockwise moment. So clockwise moment is equal to anti-clockwise moment. That is RB is equal to W into A by L. RB is equal to W into A by L. Then that is taking moment about B. So we are taking moment about B. So that W into B is equal to, that is anti-clockwise moment, and clockwise moment is equal to RA into L. So RA is equal to W into B by L. RA is equal to W into B by L. This is the reaction at A and B. Then we have to calculate the shear force. Shear force. So that is the shear force is between A and C is equal to, that is W into B by L. So now W into B by L, and that is positive because left up right down is positive. So that is positive, and that is shear force between C and B. Unit is, that is Newton. Suppose that is Newton, then that is also Newton. Between C and B, that is also, that is W into A by L, and unit is negative because left down right up. So that is negative W A by L. So arrow in the downward direction. This is your shear force diagram. Then SF diagram. Then we have to draw, calculate the bending moment, and also we have to draw the bending moment. Then bending moment calculation. For bending moment calculation, that is distance x from A. So that is R is equal to how much? W into B by L into x. So when x is equal to 0, bending moment is equal to 0. So in this point, that is bending moment is equal to 0. Then when x is equal to A, means at point C, so x is equal to A, that is bending moment, that is mx is equal to W into B by L into A, that is A. So WAB by L. So here is the unit Newton meter. This much, and that it increases uniformly from 0 to WAB by L. Then bending moment from C to B, that is decreases gradually and becomes 0 at point B, because this is the your supporting point. This is the supporting point. So WAB by L, this is the BM diagram. Then that is now are solving a example, an example that is, suppose a simple supported beam, this is a simple supported beam, and carrying suppose 3-point loads in the simple supported beam, and the total distance suppose that is 8 meter, and suppose this point A, B, C, D, E. Suppose this one is 2 meter, this is also 2 meter, 2 meter, and 2 meter. All right. So A, B, C, D. So first we have to calculate that is RA and RB, and suppose 5 kilonewton, here is also 6 kilonewton, here is 7 kilonewton. The force are applied on the 3 different points, that is point C, B, and E. So first we will calculate RA and RB. So RA is the reaction angle. So taking moment about A, taking moment about A, then that is 5 into 2 clockwise movement plus 6 into 6 means D point is how much distance? That is 4 plus 7 into how much distance? That is 6. These are all clockwise movement. Then is equal to RB into 8. So RB is equal to 5 into 10 plus 24 plus 42 divided by 8 is equal to 76 divided by 8. 76 divided by 8. 9.5, that is a Newton. Then RA is equal to how much? We have to taking moment about the point B. So that is 7 into 2 plus 6 into 4 plus 5 into 6 is equal to RA into 8. Then that is RA is equal to 14 plus 24 plus 30 divided by 8 is equal to 8. That is RA is equal to 9.5 and RB is equal to 8.5. So these are RA and RB. Then we have to calculate between A and C is equal to 9.5 kilonewton. We have to draw, that is 9.5 kilonewton. Then the shear force between C and D is equal to 9.5 minus 5 is equal to 4.5 kilonewton. That is 4.5 kilonewton. Then shear force between D and E is equal to 4.5 minus 9.5 minus 5 minus 6 is equal to 1.5 kilonewton. That is minus 1.5 kilonewton. Then that is shear force between E and B is equal to, that is minus 8.5 kilonewton. That is 8.5 minus 1.5 and that is 4.5, that is 9.5. Now we have to calculate the bending moment. So bending moment calculation, that is distance x from point A and B, distance x from A. So that is the bending moment at point C is equal to R is equal to how much? 9.5 into 2 is equal to 19 kilonewton meter. 19 kilonewton meter. Then that is at point D. Bending moment at point D. At point D is equal to 9.5 into 4 minus 5 into 2 is equal to minus 10 is equal to 28 kilonewton meter. Then bending moment at point E is equal to 9.5 into 6 minus 5 into 4 minus 6 into 2 is equal to 57 minus 20 minus 12 is equal to 57 minus 2 is equal to 25 kilonewton meter. Again decreases, and that is 0 at point B. 19 kilonewton meter, that is 28 kilonewton meter. that is 25 kilonewton meter, it is 0. This is the DM diagram. This is the diagram. Okay.